Hi, welcome to Jet Radio. I'm Ted Shire, your host, and with me today is Mark Tomer from USDA, the National Laboratory for Agriculture and the Environment. And after a few introductory remarks, we'll have Mark introduce himself and his work to you. Thanks for joining us today. So here at Jet Radio, we are dedicated to community service as a means of sustainability. And we define sustainability as everyone doing their part to better the community, because that's what it takes to achieve lasting sustainability, when everyone does their part. And so that's why it's exciting to hear about other people's contributions, and why I get excited about learning from others and what they're doing to make a difference, because every part is important, and everyone has a unique set of gifts and abilities that they can use to make a difference. And in many parts of the world, things are becoming less sustainable because of the approaches that are being taken, such as government taking too much responsibility for welfare and health care, when a lot of that can be accomplished by people helping people. Because when we help others, we help ourselves in the process. And so some of this material is from the book Everyone Needs Sustainability. That's a book I authored that describes community service as a means of sustainability, and how the four different types of sustainability interact with personal, community, financial, and environmental sustainability. So today's topic is soil sustainability, and Mark is a soil scientist with USDA. And Mark, can you tell us a little bit about your work and your background?
Sure. I appreciate being here and the chance to chat with you. I was actually raised in Ohio in a parsonage, and my dad served rural or small community and urban and suburban churches while I was growing up, and he exposed us to the out of doors, and we enjoyed the out of doors a lot when we were growing up, but I kind of fancied myself a writer or a social scientist, in my younger days. But during my first year at college, I really got interested in the out of doors, and I ended up going into forestry as a bachelor's degree, and got really interested in soils and water, and that just kind of led me down a course where I got 3 degrees, kind of majoring in soil science and minoring in water resources all along the way. So it's kind of been a lot of different things going on throughout my career, but I've been here in Ames now for 15 years and doing a variety of things relative to soils and water quality. One of the things I've been most involved with is the Conservation Effects Assessment Project, which is a nationwide project looking at impacts of conservation practices on water quality. And in the last few years, I've really been focusing on developing planning tools for water quality improvement in watersheds to contribute to large-scale problems that we've got going on in the Gulf of Mexico and the Great Lakes.
Nice. Yeah, so soil and water quality, those two seem to go hand in hand. Did you study them simultaneously or at different times?
Well, in my graduate degrees, I certainly did. I did soil physics for my master's degree and studied the movement of water through soils. And in my PhD, I looked at hill slope hydrology and the impacts of soil layering on water movement through the landscape. And early in my career, I had some interesting opportunities to look at groundwater flows through glacial landscapes in northern and eastern Montana, which kind of led to a lot of the questions that coming up that encouraged me to pursue a PhD and that topic of soil and water at the landscape scale.
Yeah. Just to a quick follow-up question. We'll get into much more of the detail later, but very quickly, how steep are the slopes that you can farm on before it begins to be detrimental?
Well, it depends on how you treat the soil, of course. The more you expose the bare soil to rainfall, the more likely it is to run off. If you look across the board, I mean, I've seen soil erosion occur on just 1% slopes, but that's quite unusual. It only happens under very severe rainstorm sort of conditions. Really, when you begin to get above 5% slopes, which is a 5-foot rise over a 100-foot distance, that's the slope where you begin to get your most significant erosion concerns. And we do farm in this country slopes significantly steeper than that, so that's why a lot of the concern about erosion comes up.
Yeah. Yeah, so that gets a little bit into definition of environmental sustainability. Let me read that for our audience. You can define environmental sustainability as the long-term capacity of ecosystems or the biosphere, which is the whole Earth, the living part of the Earth, to support life without net losses of any type that would endanger the ability of ecosystems or the biosphere to support, repair, or replenish itself. So if we damage the environment to a certain point, it can't repair itself, and so that's why we need to stay below those kinds of thresholds. So one example of that is farming slopes that are too steep. Another example is farming poor forest soils where, for decades, it's been known in the news that slash and burn agriculture. They'd farm an area, and within a few years, they'd no longer be growing because it had eroded away due to the poor management of that land. Does any of that ring a bell? Or
well, that sort of thing actually rings true with a lot of our agricultural history in our country. One of the books, if you're interested in this topic, that I might suggest would be "Dirt: The Erosion of Civilization" by David Montgomery, and he details how when the European settlers came to the eastern shore border, what's now the U.S., they started farming and growing cotton and tobacco, and they did that without any conservation methods, and often they would put their crop plants so that they were fairly well spread apart, and when they would harvest that, they would remove the entire plant and leave the soil completely bare. And so over a couple of decades of that, then that soil would wash away. And this was before in the days that there were fertilizers or anything. And so the soil stopped producing the crops that they wanted to grow. And so they picked up and moved on west. And so this kind of led a lot of the westward expansion and the numbers of people who were farmers and decided to pick up and move to other areas in the very early years of our country's history.
Yeah. No, that's interesting. It picks up just on the aspect that human behavior is the most significant contributor to whether we remain sustainable or not. And just to relate to that, that's why cultural standards are important, because if we're driven by consumption standards, then usually that's overconsumption. And currently we're consuming at about 1.5 Earths, 50% over capacity. And it's not unreasonable if projected GDP growth grows like it has the last 40 years for the next 40 years, then it could possibly go up to a 3 Earth consumption level. And so in follow-up to that, we're producing more, we're consuming more, but reducing our capacity through degradation of the land. And your specialty is soil. So what are some typical soil loss rates in the Midwest?
Well, the target that I'll back up just a little bit. USDA tries to provide technical assistance to farmers to control erosion, and has since the 1930s, when the impacts of severe erosion were first recognized. And they formed what is now the Natural Resources Conservation Service, and they provided services out to farmers across the agricultural landscapes of the country. And they decided early on that erosion needs to be limited to 5 tons per acre per year. If you actually look at that, that is, probably 5 times or more the rate at which soil naturally forms. And so, really you'd like to keep it down to about 1 ton per acre. So the question is, how many areas do we have that are eroding more than 1 or 5 tons? Unfortunately, that's a little bit too extensive under the current cropping systems that we've got out there. Especially with tilled systems, leaving the soil bare for long periods of time into the spring, from fall tillage into the spring and such, can cause, or expose the soil to spring rains and such. And so, there is a website that Iowa State operates called the Iowa Daily Erosion Project, and for every rainstorm, estimated erosion rates are posted the next day. And you can look back at the history of erosion events in this state over the past about 10 years or so now, and see what some of the heavy storms have done over the years. And you do see a lot of areas where that 5-ton kind of standard has been exceeded, and they tend to be in the steeper areas of the state, on the east and west edges of the state.
Yeah, and how much is it exceeded in the worst cases?
Oh, in the worst cases, you can get above 20 or 30 tons. You can find examples of that.
Wow, no, that's huge.
Yeah.
So,
it is.
Hey, so
again, those are estimates; they're not measurements. But
okay,
you can, one of the things you can say about erosion, if you're, driving by a field or cycling by a field, if you see erosion damage visible to your eye, just going by, that would suggest that field is eroding above that 5 ton per acre rate.
Sure.
Yeah.
Yeah, absolutely. So what about covered ground? Like, if a golf course or something like that, what would the erosion rate be on that?
Well, if you've got that vegetative cover protecting the soil, erosion rates are down near where they need to be,
Okay.
around.
Is it essentially the rebuilding
essentially,
rate?
Yeah. I mean, there's
Okay.
exceptions out there, of course. But if you've got, a good grass cover, I'm not sure, how well a golf course would be your standard, but certainly a prairie or a natural prairie or forest, very small erosion rates there.
Yeah, yeah. So again, today my guest is Mark Tomer. He is a soil scientist with the USDA National Soil Health Lab in Ames, Iowa. So historically, when did most of the soil loss occur? Was it before that 30s period, or was it after the intensive agriculture?
It was probably before then, and if you look at the history of agricultural development in the country, a lot of the areas in the South that used to grow cotton are now forested because they lost their capacity to grow cotton, and without fertilization, and those areas have never recovered back into agricultural production. It's been a long time, but a lot of those impacts are still with us. If you go along a lot of our river valleys, stream valleys, you can still see the eroded soil from the early settlement accumulated along our valleys. And you can actually calculate how much eroded sediment is there if you take the time to look at those soils along those streams. And considering a lot of the sediment losses that we've got today, many of these sediment losses are actually accrue due to past erosion events, moving soil off the landscape down into our valleys, where they can be contribute then to stream bank erosion, which is now the dominant source actually of sediment in a lot of our rivers and streams.
Yeah. What does it look like? What does that soil that's been transported to the valley look like? How do you know it was transported there?
There'll be a change in the texture. So if you have to know something about the sequence of materials that was there, but typically before we settled this area, the amount of water that would come down through our streams and river valleys would be very small, and that water would be moving very slowly. And so because of that, the materials that would be deposited along those rivers and streams would be very fine textured. Nothing more than silt size, perhaps, and a lot of clays. And after that, once the landscape got cleared and plowed, and rainstorms came along and washed that soil down into the valleys, you'd have soil materials that were somewhat coarser. And so where you've got, along these rivers and streams, where you've got a somewhat coarser soil over a very fine soil, that's where you know that you can call that this post-settlement alluvium or deposit. Yeah.
Yeah. I guess a couple of follow-up questions there. Has anyone measured the total amount of transfer there, and what is the best way to measure soil loss just on a regular farm field?
Okay. Well, I've done it in one watershed and basically ended up concluding that there was the equivalent of 70 tons of soil per acre that had eroded down into the river valley and was still there after, from those early days of agriculture. It's probably been done in a few other areas. I've written a paper that looks at some of the examples of how thick some of these deposits are. Some of the other impacts are due to mining. You can find examples of where mine disturbances brought a lot of sediment down into valleys out west, for example.
What's the thickness of that 70 tons per acre?
About 3 feet, and that extends out, about 80 to 100 yards from the stream. That's what I recall from the study we did about 5 years ago.
No, that's astounding. 3 feet of soil.
Mm-hmm.
Yeah. No, that's a big number. So in terms of obviously many of us are concerned about how much soil we're losing. So again, we respect that you have to stay within your area of expertise for the USDA, but can we speculate for a moment on how we could better measure soil loss in the future, just so that we can take better care of it?
Sure. Well, we haven't done a lot of real specific measurements because it's very expensive and to actually measure soil loss coming off of a field. And so there were a lot of studies that were done back in the 40s and 50s to help USDA be able to assist farmers limit erosion. And they did studies looking at how the steepness and the length of a slope impacts erosion, and how much cover you've got on that soil impacts erosion. And they came up with what's called the universal soil loss equation, and that's been revised a few times over the years, but it remains kind of our standard of estimating the risks that certain cropping systems that we got out there pose for erosion. In terms of measurement, what happens is the models that we've got out there predict sheet and rill erosion, which is basically what gets detached physically by the impact of the raindrop on the surface, and then being able to move that off with sheet flow coming across the surface. As that sheet flow moves across the surface, those flow paths converge, and you get gully erosion that takes place then. And the estimation methods we've got right now don't cover gully erosion. Even some of the very small gullies that form up on our farm slopes. They're called ephemeral gullies. And I'm involved with some projects where we're trying to estimate the impacts of these ephemeral gullies and what the impacts are over the long term for soils. In terms of measurements, we can model that using the tools we've got, but some of the actual mechanisms of how soil gets detached, being able to measure that directly has been very difficult. But I've seen some of the techniques that have come through lately using remote sensing and photogrammetry, actually setting up photographic methods out in the field that allow you to look at changes in topography that are just a very small fraction of an inch. And I think as we move forward with some of these technologies, we'll be able to improve our soil erosion models.
Yeah. No, thanks for sharing that. Mm-hmm. That's enlightening. So we're here with Mark Tomer, soil scientist with USDA, National Laboratory for Agriculture and the Environment in Ames, Iowa. And we're going to go to a break here. We've been talking about soil sustainability. And when we come back, we will continue that conversation. Thanks for joining us today.
I'm Brian Leach, owner of Service Legends, and my position is Chief Talent Officer.
I'm Nicholas Wonderscheid.
I am Bernie Homs.
And I'm the Service Manager.
Marketing Director and Client Relations Manager.
Everything that we do is about ensuring that we exceed your expectations.
Our clients are important to us. 100% satisfaction.
We're not just focused on heating and cooling. That's the easiest part of our job, actually, is fixing furnaces and air conditioners.
Everyone that we come in touch with, we want to improve lives.
Bottom line is, we've got our installation guarantees, 25% energy savings guarantee, comfort guarantee, temperature selection guarantee, property protection guarantee.
100% satisfaction guaranteed, fixed rate or it's free.
All of those guarantees are backed up with a 100% money-back guarantee to hold ourselves accountable to making sure that you get what you're after.
Just fixing the problem today. If they have another problem 5 days down the road, it's still fixed rate or it's free.
We use what's called straightforward pricing. Our technicians are going to give you an exact to-the-penny price on what it's going to take before they move forward with any repair. That way you know what to expect.
It's the same price every day.
No surprises.
If you get off work at 5 o'clock in the afternoon, you come home, you realize that, my furnace is broken. Now you need to call somebody out that night. You shouldn't have to pay more for that.
We're guaranteeing service 24/7.
We run afternoons, evenings, nights, weekends. We're staffed to work that.
Phone rings at 3 in the morning. You'll get one of our representatives answering the phone every time.
We're not sending you out to Timbuktu in some call center. It's our Service Legend team members, our mission control team.
I'll take a call anytime.
And then they answer the phones the same way during the day as they do at night.
It's a great day at your service company. How can we make you smile?
That's the only way to provide true 24-hour service.
When you're able to let somebody actually live in their home safely when they weren't able to do that before, where they don't have to stay up at night and worry about, is the heat going to come back on? Are we going to freeze the pipes? Is the baby in the room next door going to be sick because they got too cold? When you're able to help somebody overcome challenges like that, that's impacting a life. That makes a difference. I get goosebumps thinking about it.
I love the team. I love the people that I work with.
We have fun, but we work hard.
I call them my ambassadors of legendary service. If you could just envision what that is, that's who we're sending to your home.
They literally will call in, pick up the phone and call and say, hey, I want to talk to your manager. And I get on the phone, they're like, that technician that was at my house was the greatest technician ever. That's cool to me.
We want to brighten people's days.
Every person that we have going into the house has gone through an extensive background check.
Drug testing, we have a very thorough interview process that 1 out of 140 people make it through.
If we promise you something, that's what you're going to get, no matter what.
We're here when you need us to protect the safety and comfort of your family.
If you're not happy, we're gonna make it right.
If we're willing to put 100% money back guarantee on what we do, what type of work do you think we do?
Give us a call. We're there for you 24/7, 365 days a year.
Enough said.
Hi, welcome back to Jet Radio. I'm Ted Shire, your host, and with me today is Mark Tomer. He is a research scientist at the USDA, National Laboratory for Agriculture and the Environment in Ames, Iowa. And we've been talking about soil sustainability today, and want to pick up there again. And Mark, we know we've got good soil here in the Midwest, but who else has good soil around the world? Or even what is soil like at other places in the world?
Yeah, well, you're certainly right about the soils we've got here. I mean, we've got some of the world's most productive soils here in the Midwest. We're absolutely blessed to not only have the quality and the depth of the soils that we have here, but also the climate that comes along with that to provide the magnitude of the crop production and agricultural system production that we've got here. In terms of highly productive soils that we've got around this country. I'll start with North America first, I guess, and it's not only the Midwest areas of southern Ontario also have very good soils. Probably a lot of the eastern seaboard originally had very productive soils, but after they were eroded away, we can't really count on them for the type of production that we see in the Midwest right now. If you look at the most inherent productivity we've got in our soils and around the rest of the country, I'd probably point to a couple of areas. The northern Great Plains, where we've got our small grain farming systems, from Texas up through Montana and yes, into the Canadian provinces. Those areas are a little bit drier, and so you don't see the magnitude of production, but you get extensive areas of good quality grain production out of there. In the Pacific Northwest, we've also got some really good soils as well. The Palouse is an area of wind-blown soils in eastern Washington and Oregon. Some of the most productive cropland for small grains anywhere in the world. Outside of that, I mean, you'd probably look at the Russian steppes, and there's some areas in northern China. Rice production tends to take place on fairly productive soils, and so if those systems are managed well, rice paddy soils are very productive. And I should mention that some of that goes right on down includes some of the Mississippi Valley soils that we've got, where we've got good rice production down in those areas. But if globally, if you look at it, we've got a lot of degraded soils, and the United Nations came out a few years ago and talked about the extent of degraded soils that we've got around the planet, and it's unfortunate how extensive soil erosion and soil degradation, desertification has become globally. If you look at a map of where poverty is most extensive in the world and where soils are least productive in the world, you'll see a remarkable similarity between those two maps.
Yeah, and that gets back to your referral to Montgomery's book, Dirt.
Yes, to a certain extent, yes. But David Montgomery goes into more history, I would say, and looking at the difference between civilizations that flourished over a long period of time and those that diminished in time, and what do we know about the way that those civilizations managed their soils? And he's got some very interesting conclusions there. Yeah.
What does he say about soil management? Can you give us a little quick tour of soil management?
Well, yeah, it boils down, I think, to three things, and if and I think we do two of those things well here in the Midwest, and are starting to do them better at least. The first is to manage your nutrients and the cycling of nutrients. You can, if you don't have fertilizers, you can do that with animal manures, for example, providing plant nutrients back onto your farmed fields. The second piece is controlling soil erosion and how critical that is. So systems that recognize when most of the heavy rains and when the soils might be most susceptible to soil erosion, they make sure they've got protective cover on those soils at that time of year.
Yeah. So essentially, if we were able to have a good management system that kept our soils covered, we wouldn't have that much to worry about. Is that correct?
I think that's true. And so, it's not just good nutrient management, but limiting tillage as much as possible. And and I speak with farmers, the idea is to do as little tillage as possible, none if you're comfortable with that. The two terms that we could use would be, well, I guess I would call it Z tillage, zero tillage, or zonal tillage. So Z tillage would be like no tillage. You only disturb the soil to actually plant the crop so once each year in the slot that you drop the seed in, and the other one being zonal tillage, where if you've got a field and your row spacing is say 2 or 3 feet across, that you only cultivate a 4 to 6 inch wide zone, and so you're only disturbing a very small fraction of the area. And I've seen fields that are managed like that. That's called strip tillage. Mm-hmm. It's a new technology that's out there that can be used in Iowa, but it takes new equipment. You've got to be able to drive over that, exactly within an inch that same area on successive trips across the field. And so you've got to have really good navigational systems on your tractors that are out there.
Yeah. What's the percent exposure in a strip till scheme?
Oh, 10 to 20%, I would guess.
Okay.
Yeah.
All right.
Yeah, the rest of it is not disturbed.
Yeah, no, that's excellent. So what about the soil survey? Can you tell us a little bit?
Well, let me back up, because I said David Montgomery talked about 3 things, and the third thing is absolutely critical, in terms of soil health. And so it's limiting nutrient loss, it's limiting soil erosion loss, but the other thing is to recognize that soil is a living system, and to actually have part of your crop rotation be there to favor the health of your soil and improve the health of your soil. And so a lot of this boils down to soil organic matter. How do we increase soil organic matter? How do we maintain it and increase it? And one of the practices that we're trying to encourage here in Iowa is cover cropping, which rather than leave the soil bare over the winter, you would plant a winter hardy grain crop, allow that to come up in the fall, cover the soil over the winter, regrow in the spring, and then you take that down then before planting your corn or your soybean crop. And that's something that our lab and a number of other folks have been working on in the Midwest, and slowly but surely we're seeing more producers take up this particular practice.
Mm-hmm. And are the markets pretty good for cover crops? This is not something that's sold. This is actually, it's not something you harvest off. Okay. The field. You use the growth and recycle that material back into the soil to improve the soil organic matter. Nothing wrong with that.
Yep.
So the USDA has a soil survey, correct?
Mm-hmm. Yes.
Can you tell us about that?
Well, it's available nationwide. It was a long-term, multi-decade project to actually go out and map our soils, but it gets into soil classification. We've got 11 soil orders. They're basically are divided along lines of the age of the soil, the weathering of the soil, what was the native vegetation of that soil, and these have major implications for the basic characteristics of the soil. And then you can subdivide that on down into from orders to grade groups to groups. But the soil survey itself then maps out the distribution of individual soil series, and those are kind of delineated out to be able to identify the appropriate use and the limitations to use for each individual soil type, and gives you some idea of where the most productive soils are in your area as well, if you're to look at the soil survey for your county, for example. Mm-hmm. And they are available on a county basis nationwide.
No, that's great.
There's there's a lot of detail that goes into it, but that's it in a nutshell.
Mm-hmm. Yeah. So, do you use that information in your framework plan?
Yes. I mean, soil characteristics have an impact on the on the usability of the ground and the farmability of the ground. And what I've done is to identify, or look at soil characteristics along with the terrain and the land use that we've got, to be able to identify places where we could obtain water quality improvements without taking much land out of production.
Mm-hmm.
Yeah.
Yeah. So give us a brief overview. We're going to get into this in a little bit more detail here and put up the pyramid here in a little bit. But give us a brief overview of some of the major components that go into a soil conservation and water purification scheme on a farm.
For a farm?
Yeah.
Well, that pyramid slide actually does a good job of that. I think the basis of it actually does come down to those three aspects. And so if you look at how do we improve our soils and our watersheds and our stream water quality all at the same time, rather than pick this thing environmental quality on our ag landscapes, just one issue at a time. How do we look at this in a more holistic way? And it's something I've spent a lot of time thinking about. And how do we give farmers options for addressing these problems that we've got out there? So I started to look at it as kind of a tiered system, and it's on this pyramid chart here. It begins with building the health of that soil, limiting excess nutrients, controlling erosion, but then also practices like cover crops to maintain and increase soil organic matter. If we do these things on our soils, we'll get better infiltration rates. So when it rains, you're going to have less runoff. We'll have better water holding capacities. So the rainwater that infiltrates tends to stay in the soil, where it's available then for plants to get more productive growth, rather than leaching through the soil and taking nutrients with it. And we've got issues with that certainly around. So if we can actually build our soils to minimize the amount of water that's coming off, that's kind of the first step. We won't change the fact that agriculture is inherently a leaky system. Rain often comes in larger quantity than we need it, or the soil might be able to handle it. But when those events come along, anything that we do at the edge in the field or at the edge of the field and on down the track is going to be it will work better, because there's going to be less volume coming off and such. And so, the sort of practices that we might also include, there's things you can do, and maybe put the framework, the triangle back up there. So, build the soil health wherever you can. And then, thinking about controlling water movement in the fields. A lot of this depends on what the slope is. So if you've got a drainage system, maybe you can kind of moderate or gate that drainage system if it's a very flat field. If you've got a sloping field, there's different things you can do to filter runoff as it comes off a field, and different types of practices. And then off the edge of the field, there's other things you can do to trap and treat nutrients and runoff, detain waters a little bit more. And then all the way down into the stream zone, what sort of practices can we put along the streams to buffer them from the impacts of the surrounding land. And it's being able to map out all those opportunities has been something that's been beyond our capability up until very recently. But what we've got now is a mapping capability that includes that's based on a laser altimetry. So they put this equipment up in an airplane and cover the entire landscape, and they use lasers, and they get a very detailed topographic map of the land surface. And what you can tell from that is the very intricate detail of how water can move over the soil surface. And if you combine that information with knowledge of how that land is being used, okay, and also what soil types are encountered as that water moves across the landscape. That gives you an idea of what possibilities are for putting different practices out on the ground. And so what we're doing with our system then is to build an inventory of these conservation opportunities to control water in the fields and at the edge of fields. And there's a whole suite of different practices that can be used for that. But the idea of the framework is to be able to map out all the different possibilities, provide that as an information base then to local communities who need to grapple with these issues and determine how best to address water quality in their particular community.
Yeah. No, thanks so much for sharing that. Again, we're talking with Mark Tomer. He is a soil scientist with the USDA lab up in Ames. We're going to take a break here, but when we come back, there's some more follow-up on that issue and how to design farm systems to minimize erosion and maintain soil and water quality. Thanks for joining us today.
From the RE/MAX Real Estate Concept Studios, this is Webcast One Live.
Credit cards are like grandkids. They love you, sometimes get out of control, and it's fun to get a new one. Who can stop them from piling on?
Hi, I'm Tom Coates with Consumer Credit of Des Moines. At the end of the day, you can return the grandkids, but you're stuck paying off bad credit card debt. We'll help you put the fun back into using credit cards responsibly. Right, kids?
Yeah! If you need help getting credit cards off your back, call Consumer Credit of Des Moines.
Hi, welcome back to Jet Radio. I'm Ted Shire, your host, and with me today is Mark Tomer. He is a soil scientist with the USDA National Laboratory for Agriculture and the Environment in Ames, Iowa. And we left off talking about some of the ways that we can conserve our soil and purify our water by the way we design farmscapes. So, Mark, can you take us through some examples, and we have some pictures as well, of some of the simple things that we can do to help both improve soil conservation and purify water.
Sure. Well, once we've got a healthy soil in place, what we do then is the best identify the best opportunities then to filter and runoff and water moving off the landscape, and one of the things to think about is not only the scale. Are we putting the practice in the field, at the edge of the field, down below a set of fields, but also what flow pathway is it addressing? And we consider two different flow pathways. One being tile drainage, and tile drainage is fairly ubiquitous in a lot of central Iowa for agriculture. And most of Iowa was a complex of wetlands prior to its settlement, and it's only able to be farmed because of these drainage systems that we've got out there. Mm-hmm. It unfortunately does carry a fair amount of nitrate with it, and so the question is, how can we actually kind of modify these systems to reduce that threat of nitrate leaching? And here's just a few possibilities. We can put gates on over the winter. We can run the tile drainage through wood chips to help remove the nitrate that way. We can widen out our drainage ditches so that the water moves down through those a little bit more slowly, perhaps, and can interact with some of some of the plant roots and such of a small riparian zone along that ditch. And we can put in wetlands in particular places in the landscape. If we can find those locations, we're putting in a low impoundment that you see there in the, like you see in the lower right. If you can put that impoundment in without backing water up into the tiles that are contributing water into that setting. And so, you know, where are the not all these practices can be placed anywhere. And what we try to do is to map out these different possibilities. If we go to the next slide, so that was the tile drainage pathway. We've also got surface runoff. So what sort of practices do we have out there for surface runoff? And here's just a few of them: contour strips, contour filter strips, grass waterways that control gully erosion, places at the bottom of the fields you can actually help trap sediment if things do get away from you. And then on our very steepest lands, most susceptible to soil erosion that are hardest to farm, maybe we can think about conservation cover in those areas. We could use some of those areas perhaps for biomass production, which would give us biofuels, but would involve a lot less soil disturbance than the cropping systems that we've got out there. And so where are the places on the landscape to put this whole entire suite of practices? When we look at a series of watersheds, we see lots of opportunities out there. The idea isn't necessarily to say, you know, come up with a specific solution, but to give folks in the local communities an inventory of possibilities for them to pick and choose from among those practices and come up with ways on their own to use this information to come up with their own customized approach based on the particular landscape and on their farming operations, because they have to consider that as well.
Yeah. So is it typical to that variety is best to use more than one of those examples on the same farm?
You know, absolutely. And I think that's part of the problem we've gotten into the situation we have with water quality is, you know, there's always been that search for that silver bullet. What's that one practice that'll solve the problem? And there isn't one. There's no single solution out there. The best situation or the best solution is specific to that location.
Mm-hmm.
I mean, and so what are those possibilities?
And your program helps to identify those,
yeah,
right?
so we've come up with a set of software then to help map out all these possibilities. And you know, I've been leading this effort with some folks who can write the programs and pull the data together. And we're fairly far along that track. We actually had a training session for 25 folks who expressed interest to come in and get trained on the software, and they've taken it back to their workplaces. There's several universities involved. And a couple of engineering consulting firms doing watershed work, a couple of NGOs also, and we're getting some fairly good suggestions and feedback on how to refine these tools.
Yeah.
But also a lot of excitement. Some of them are taking the products out, you know, the map products out to show the farmers, and some of those things are being very well received, and you know, as a good starting point for discussion about how to approach this problem at the local level, which is really the only place we're going to be able to do it.
Absolutely. So tell us the names of those software tools and how they can be obtained.
Well, we're only in beta form right now. We haven't released it for anyone to download at this point. We're hoping to do that still this year. We're still refining the tools, coming up with a final release version, and of course documentation to be able to use the software for folks who might be interested in doing that.
Okay, gotcha. No, thanks for telling us about that. So how much of the land is needed to help conserve the soil and purify the water?
Yeah, well, what we've done to evaluate different planning scenarios and what we do to kind of help, you know, provide a starting point for discussion is not only provide all the information about here's where all these practices might go, but to pick and choose a couple of combinations of practices and how they might be distributed in a given watershed. And what we found is that we can probably address this problem depending on the preferences of the producers and the nature of the particular watershed by taking out somewhere between 2 and 8% of the cropland in a watershed, which isn't really that much. One of the things that really helps keep that land taken out of production down is to put in a practice like cover crops to help limit nutrient losses. That practice does a very nice job, not only of increasing soil organic matter, but by doing that, it also reduces nutrient leaching at the same time. That's what the studies have shown, and there's good reasons for that would be the case, because the more organic matter you've got, that's where the cycling of nutrients occurs in the soil, and so the more you can encourage that nutrient cycling in our soils, the less susceptible to loss they are.
Yeah, that's excellent. So how does it increase the holding capacity of the soil?
Organic matter, well, you can think of it as the sponge of the soil, if you will. So soil is made up of sand, silt, and clay, but it's not just like a paste of these materials. It naturally forms into little clumps, and if you look at an individual particle or aggregate of soil is what we call it. There'll be a lot of particles of sand, silt, and clay that are glued together, and it's the organic matter that glues them together. And the fact that these small aggregates are formed in the soil and are able to be stable in soil, that's what actually imparts the water holding capacity of the soil, and also the gas exchange, because roots need oxygen to grow well, and well-developed soil with healthy organic matter, a healthy biology will also let a lot of gas exchange for rootability of the soil.
Yeah. So there's so many advantages.
Yeah, it keeps the density down as well. So just physical attributes like how hard does a plant have to push a root through a soil? The harder it has to push, the less growth you're going to get out of that crop. So if you've got compacted soils, they're going to be less productive, even though they might be, completely similar to a non-compacted soil. There'd be a huge difference in production between them.
So what is it? So yeah, that's a perpetual problem. We need the soils to be uncompacted in order to cultivate, in order to grow crops. But how do you uncompact the soil without exposing it to too much erosion?
Yeah, I mean, that's something that producers have struggled with over the years, and there have been deep ripping and a lot of types of practices that might basically tear up the soil. It takes a lot of power to be able to do that, a lot of fuel. One of the things that is out there right now is a particular cover crop, a type of radish. It's called a tillage radish that puts this great big fat root down a couple feet and can break through some of these layers. And if you can do that, you've got a fairly inexpensive solution to the problem.
And that adds organic matter at the same time?
It will also add organic matter at the same time. So that makes that issue less likely to recur in the future.
Yeah. Is that pretty economically feasible?
Yeah, I mean, it's a cover crop like any other, like the one I described earlier. And so there are a number of companies out there that sell tillage radishes. It's like planting any other crop. It's just that you probably aren't going to harvest it, maybe a little bit for forage, but mostly it's a crop that you plant kind of off during the off season to help improve the soil.
Yeah, no, great. So, you design a custom scheme for soil conservation and water purification.
Yep, water quality, yep.
What is it that so little of the land, 2 to 8%, that you can do some simple things to clean up that excess nitrate or whatever the case may be? Why is it so doable? Why is it so easy
To find those locations, well, it is the idea of finding the right place to do that sort of practice. And the fact is, if you look at water flow pathways as they come off the landscape, they converge before they enter the stream often. And so those places tend to be those where we can put in these type of practices. They will often be located in areas of the watershed that are most difficult to farm. And so in some ways, even though you're taking a little land out of production, the other side of the coin of that is that maybe it's freeing up the farmers to do what they do best on the land that responds the best to their crop management activities.
Mm-hmm. No, real good. So what about the wetlands? Is that something that creates a significant increase in the number of wildlife there?
Yeah, certainly. Yeah, I mean that's I'm not a wetland ecologist or anything like that, but I'll just say that there are a number of different types of wetland. They each have their own ecology. They've been disappearing off of our landscape. There's less than 1% of the original wetlands in Iowa are still there. Some of these areas that are being put in for nutrient removal wetlands, do bring a few of those benefits back.
Mm-hmm.
Yeah.
Yeah. So bringing it down to practical matters, can conservation help farmers increase their profits?
I think there is good examples out there. If you look at some of the videos that are out there, I mean, NRCS has got a nice series of videos on cover crops with interviews with farmers who have been trying cover crops for a number of years, and what they say is that the improvement in the soil that they see from using these practices increases the nutrient cycling in their soil so that they can actually produce just as much crop with little or no fertilizer added, with just a fraction of what they used to add at most, that the water holding capacities allow the crops to grow, and you basically have the same or better yields with lower costs, and that's what we're hoping that we can do with practices like cover crops. Is we can perhaps reduce the cost of farming, not necessarily jump the productivity way up, but reduce the cost of farming.
Sure.
In some of these areas, yeah.
Yeah, pesticides, herbicides, fertilizer, that's not cheap, is it?
Right. No, it's not at all. It's not without its challenges. If you look at some of the best examples, success stories, they come from southern Iowa, southern parts of the Midwest. As you move north in the Midwest, we get these cold falls, and with late harvested grain crops, it's a little hard to get in and establish cover crops, but there are a few folks out there who are attempting to do this, and I've worked with farmers since the mid 1980s, and I know that wherever there's a farmer who's determined to make a system work, who believes they can make a system work, that they're seldom unsuccessful. They're actually very farmers are very ingenuitive types of folks, and are when they decide to think outside the box and make a new system work, they can do it.
Yeah, absolutely. No, with the best soils in the world, we can do a lot.
Absolutely.
So,
yeah.
So, Mark, thanks for joining us today. With us today has been Mark Tomer from the USDA's National Laboratory for Agriculture and the Environment in Ames, Iowa. And he's been helping us to understand soil sustainability better and how we can also purify our water at the same time. Thanks for joining us today on Jet Radio. And we will join you again next time, continuing with our theme of different ways and different types of sustainability. Thanks for joining us today.